This is question 1B of the practice exam. Now in this case here, you're given the temperature dependence of a rate constant. So in this case here, that's Arrhenius law. So if you remember your equations for Arrhenius law, K equals A, e to the minus EA over RT. This is your rate, or your rate constant. A is called the Arrhenius constant. That's going to depend on the particular reaction. You have your activation energy, gas constant, and your temperature. Remember, we can also break this down to ln K equals ln A minus EA over RT. So when you plot this, which is shown actually in your exam, you can plot ln A there, versus 1 over T. You should end up with a straight line that is showing you, sorry, not ln A, ln K. Get that back, ln K versus 1 over T. And the slope of that line should be minus EA over R, according to your Arrhenius law equation. So the first part of this question wants to know, what is EA? So you're going to get that directly from the slope that you are given. So we know slope equals minus EA over R. You know, R is 8.314 joules per mole Kelvin. So in this case here then, where's my answer? Right. So EA is equal to minus R times the slope, which is going to give you a value. And look at your slope value is K, right? Is in temperatures. And the temperature unit. This is going to give you about 100, and I'm converting to kilojoules from joules, 100 kilojoules per mole. So you get something around there. Now, part 2 of this question wants to know T2. They're giving you a K2 value, they're giving you a T1 and a K1 value. Okay, so this is one of those questions where you're trying to find one of the temperatures given these others. Now, if you remember back to your equations, if you use the equation ln K1 over K2 is equal to EA over R times 1 over T2 minus 1 over T1. So you know K1 and K2, you know EA, you got it from up here using the slope. You know T1, you just need to solve for T2. And going through this and solving for T2, you should end up with a value of about 306 Kelvin. And that's it.